In this video, I'm going over our lesson 1.3 on quadrilaterals, but in this lesson, we're just going to be focusing right now on the sides and angles of the quadrilaterals. So before we get into it, though, there is this review question. So go ahead and pause the video and let's see if you remember, given that this is a parallelogram, you're solving for x, y, and the side LM. And here we go. So solving for x, well, I notice that x is side LM here and side ON here, which are opposite sides, which are not only parallel, but also congruent or equal to each other. So you just had to set them equal to each other and then solve for x. So here you could gather your variables. So here, and now you're just solving a two-step where you would add 7 and then divide by 4. So x was equal to 4. Then here, solving for y. Well, y is here. So y squared plus 3. So again, opposite side. So I'm going to go ahead and use that value of 12. So y squared plus 3 is equal to 12. So now solving for y, well, adding 3. So you should have subtracted 3 first. Now I've got y squared is equal to 9. Then just take the square root. Now before, when we solve these, you would say positive negative 3. However, now that we are applying this to this side here, actually, you could also have that positive negative 3 because again, if I have y squared here, 3 squared plus 3, well, that is 9 plus 3, which is 12. Also, if you have negative 3 squared plus 3, notice how negative 3 squared is also positive 9. 9 plus 3 is 12. So that's why here, in this case, to check, you still have that positive negative 3 value. Now, we are solving the last part for LM. LM was back to the 6x minus 7. So if the side LM is equal to 6x minus 7, we need to know the value of x, which was 4. So 6 times 4 minus 7. So you should have gotten for side LM 17. So now again, reviewing our attributes of our parallelograms, notice how the parallelogram is kind of like that guiding quadrilateral, then going down into the rhombus, the rectangle, and the square. Now keep in mind, I'm going to go ahead because we're not going to focus on the diagonals today, so I'm not too worried about that. We're going to focus on that in our next lesson. But again, here we'll still stick with our attribute here to see if y'all remember, because we talked about this previously. So with parallelograms, what can we say about the opposite sides? They are not only parallel, but they are also equal to each other or congruent. And opposite angles, what can we say about them? They are congruent. What can we say about consecutive angles? They are supplementary. Then what did it mean when they were supplementary? They add up to 180 degrees. Now let's see if you guys recall, and we talked about this and solved some problems. What can we say about the diagonals? What do? They bisect each other. They cut each other into two equal pieces. So now as we branch down, technically the rhombus, the rectangle, and the square have all of those parallelogram attributes. The opposite sides, the opposite angles, consecutive angles, the diagonals bisect each other. However, what makes the rhombus different is not only those parallelogram properties, but what else can we say now about all sides of the rhombus? They are congruent to each other. Same thing with the rectangle. Again, you have all of the parallelogram properties, but now what can we say about the angles? They are all right angles. So all angles are congruent. Same thing for the square. Along with all of those parallelogram properties, what can we now state about the square? All sides are congruent and all right angles, all congruent angles. So again, keeping in mind, this is what our focus is going to be today, but now looking at the quadrilaterals on a coordinate plane. So like for example, you're going to have to prove that shapes are a parallelogram, a rhombus, a square, or a rectangle by identifying the lengths of the sides, whether they're parallel or perpendicular, because then that's going to also help identify the angles if you have right angles for the rectangle and square. So like for the first example, we're going to go ahead and identify and start with the sides. So here I have side AB. So side AB, we can find distance and the slope, right? Because we're looking for parallel sides. We're going to go ahead and do both. So here, thinking about it, right, like Pythagorean theorem, creating that right triangle so that we can calculate the distance as well as the slope. So here the rise is 1, 2, 3, 4, 5 over 1. So this is also for Pythagorean theorem to find the distance. So the length of AB, side AB, is 5 squared plus 1 squared is equal to C squared. Then we go through and solve. So 20, not 26, sorry about that. I was jumping the gun, sorry about that. 25 plus 1, which is 26, is equal to C squared. So again, taking the square root. Now I can't simplify, so the length of AB is the square root of 26. Now we can also find the slope as well, because our slope is going up and the rise was 5 over 1, making a slope of 5. So that is side AB, the distance and the slope. So now let's go to side BC. So side BC now. So here, again, creating like our right triangle, rise and run. Rise is 3, run is 4. So now here, to set up the distance, 3 squared plus 4 squared is equal to C squared. Go ahead and solve. Let's see what you get. And here we go. So I've got 9 plus 16 is equal to C squared, which gives you 25. However, that's not the distance, right? Take the square root. So the length of BC is equal to 5. Then the slope as well. Now notice this is going down, so the slope is negative. We're decreasing. And the rise is 3. Oops, sorry about that. The rise is 3 over 4. So negative 3. Oops, sorry about that. Negative 3/4. So now let's go to side CD. So side CD. Again, my rise and my run for side CD. And that is equal to, again, my rise is 5, my run is 1. So what do you notice? The opposite sides, AB and CD, have that same length for the right triangle. So is our answer going to change if I use Pythagorean theorem again? No, because you still have 5 squared plus 1 squared, which will give you the square root of 26. And same steepness. Rise is 5, run is 1, going up positive. So the slope is 5 as well. So now let's check side AD. So side AD. So here I've got my rise and my run. My rise is 3. My run is 4. Again, notice the opposite sides. Rise is 3, run is 4. So same side lengths for the right triangle, meaning AD is also going to be 5. And the slope still going down, negative 3/4. So we have just proven that this is a parallelogram. Well, what's one thing? The opposite sides are what? They're congruent. So the opposite sides are congruent. And are they parallel? Yes, the opposite sides are congruent with our distances of the square root of 26 and 5, and parallel because the slopes are the same. So keep in mind, we have that. Now, we can also state, because technically, if I just state that the opposite sides are congruent and parallel, we could still technically state that this is a rectangle. So what else do we need to add about the angles? How do we know that the angles are not right angles? They are not 90 degrees. How can we tell? By the slopes, because the consecutive slopes need to be perpendicular or the negative reciprocal. Well, notice the slopes, though, were 5 and -3/4. So these slopes are not perpendicular. They are not the negative reciprocal of each other. So these angles are not right angles. So we do need to make sure that we are including that in when we're identifying the parallelogram versus the rectangle, rhombus versus the square. So now let's take a look at example 1b, making sure that we have our rhombus here. So again, side AB. So side AB, how about you go ahead on your own, set up. How are we going to set up for Pythagorean theorem to find the distance of AB? Well, you should have counted 4 and 1 to set up 4 squared plus 1 squared is equal to c squared. So go ahead and solve for the distance on your own, and also go ahead and identify what is the slope on your own as well. And here we go. So here you should have gotten 16, sorry about that, 16 plus 1, which is 17 equal to c squared. Taking the square root, you can't simplify the square root of 17. So here, AB, you should have gotten, has a distance or a length of the square root of 17 with a slope of going positive, up 4, right 1, so a slope of 4. So now go ahead again, try and set up BC. So what is the distance and what is the slope of BC? And so for BC, you should have noticed, again, 4 and 1, which is the same side lengths of the other right triangle, meaning we still have 4 squared plus 1 squared, which means the side length of BC is also the square root of 17. However, the slope now is different because now the slope is still positive, but the rise is now 1 with a run of 4. So you should have gotten a slope of 1/4. So now go ahead and try the other two sides and see what you notice, side CD and side AD. And here we go. So side CD, if you identified, you would have noticed, you should have, again, got the side lengths of your right triangle of 4 and 1. So it would have the same setup, right? 4 squared plus 1 squared is equal to c squared, leaving you with the square root of 17. Then the slope is also rise is 4, run is 1, just like the opposite side. So the slope is 4. Same thing for AB. You should have also identified that this was also the square root of 17 because the side lengths are 1 and 4. So here you've got the 1 and 4. However, the slope is not 4 because the rise was 1 with a run of 4, making that opposite also 1/4. So again, now all the sides are congruent, making this a rhombus, and the opposite sides are parallel to each other. However, why do we not have a square? Because if you just stated that all sides are congruent, then technically you could also have a square. So what do we need to add? How do we know that the angles are not right angles? Because the consecutive sides are not perpendicular slopes. You had 4 and 1/4. fourth. So if I have 4 and 1/4, yes, they have the reciprocal, but what makes them not perpendicular? What's missing? Negative. If you had a slope of +4 to make it perpendicular to make the 90-degree angle, you needed a slope of -1/4. So keep in mind that difference between the rhombus and the square. So now go ahead and pause the video and try the U-try on your own. Identify these three shapes, but making sure that you identify too what are the distances and what are the slopes of those sides. And I forgot to mention here, I noticed that when I was going through, this last quadrilateral here had no labels. So I would suggest if you wanted to, because this is how I would be explaining, I'm identifying as A, B, C, D when I go through my explanation for this third problem. And here we go. So for our first quadrilateral here, W, X, Y, Z. So like, for example, side WX. You should have gotten that the length was the square root of 41 because when you create the right triangle here, you have the side of 4 squared plus 5 squared is equal to c squared, which means that the slope you should have also gotten is positive 4/5. Then as you kept going, the side of xy you should have also noticed was the same, 4, 5. So the square root of 41, but now you should have gotten a slope of -5/4 because now you're going down and the rise is 5/4. So here, then, you should have noticed the opposite sides were all the same. So like here, the side YZ, you should have also gotten the square root of 41 with a slope of 4/5. And then lastly, the side WZ, again, square root of 41 with a slope of -5/4. So again, for those, if you maybe got -4/5, here, when you are identifying, make sure to identify your rise over your run. The rise here is 5 with a run of 4. So now notice you should have said that this was a square, not a rhombus, but a square. So yes, all the side lengths are the same, but now what makes this a square? How do we know that we have right angles now? Because the slopes are negative reciprocal. Now you have that perpendicular relationship creating the 90-degree angle. So again, that's why this first one was a square and not a rhombus. So then for the next one, side EF, you should have gotten the square root of 18. Then for good practice, those who simplified, you get 3 radical 2. Now, then the slope you should have gotten is 1 because again, when you have your rise and your run, you end up with 3/3, which is 1. Then 3 squared plus 3 squared was 18, taking the square root of 18. Then here you should have gotten side FG, which here was the square root of 20. Then for those who simplify, 2 radical 5. Then the slope is -2 because again, now you're going down. So the slope is negative with a rise of 4 and a run of 2. So you have 4/2 making -2. And also for that side length, you have 4 squared plus 2 squared, which gets you that 20 and then square root of 20. Then here you should have noticed those opposite sides were the same. So side GH, you should have gotten the square root of 18 with a slope of 1. And side EH, you should have gotten the square root of 20, or again simplified, with a slope of -2 here, which means now we do not have right angles, but the opposite sides are the same and they are parallel. So this was your parallelogram, which is A. Then lastly, Here you have the side AB. So side AB, you should have gotten the square root of 32. Now for those who simplify, 4 radical 2. Then with a slope of 1. So then here you have side BC. With the distance, you should have gotten 128, which simplified is 8 radical 2 with a slope of -1. Because again, for those who were identifying that rise and run, you could have used the coordinates in this case. So like my rise is from 7 to 11, which is 4. My run is from -5 to -1, which is also 4. So here's your 4 over 4, making slope of +1. And then leading you to the square root of 32 from 4 squared plus 4 squared. Same thing here. If you are identifying the distances, here your rise, you went from 3 to 11, which is 8. Then here, your run, you went from -1 to 7, which is also 8. Notice how now the slope is down, negative. We're decreasing. So that's why it's -8 over 8, which is -1, and leading you to the distance. Then you should have noticed the opposite sides from your counting were the same. So square root of 32, or simplified, with a slope of 1, and side AB. Oh, I put side AB, sorry about that. Side CD. And then side AB was the square root of 128 and simplified with a slope of -1. So again, we have the opposite sides are congruent and parallel. However, this is a rectangle. So now what makes this shape now not a parallelogram, but now a rectangle? How do we know that we have right angles? Because we do have the perpendicular slopes. Because this is 1 over 1, which is 1, and -1 over 1, which is technically the negative reciprocal because you can still flip it and still the same. So now with our last problems here, you just need to identify what is the missing coordinate given 4 of them. Like for example, M is at 1, 2, N is at 4, 4, and O is at 7, 2. We are looking to see where does the coordinate P need to be to make this a rhombus. So again, we have 2 of the sides. So here, using and thinking about the attribute of a rhombus, well, not just opposite sides, but all sides are congruent. So I notice I have 1, 2, 1, 2, 3, right? 2 and 3. 1, 2, 1, 2, 3. So really that means we need to continue as if like a slope of 2/3. 1, 2, 1, 2, 3. Notice here, 1, 1, 2, 1, 2, and 3. So this creates your rhombus. So point P needs to be at the coordinate of 4, 0. Go ahead and pause the video and try the U-try on your own. And here we go. So here you are looking for a parallelogram. So here we've got M at 0, 0, N is at 4, 1, so 1, 2, 3, 4, 1, and O is at 1, 2, so 1, 2. Now you are looking again for that parallelogram where now the opposite sides have to be parallel and congruent. So right now, looking at this slope, for example, I have 1, 2 over 1, so a slope of 2. Then here, the next side has a slope that's negative with a rise of 1 and 1, 2, 3, so slope of -1/3. I'm going to go ahead and continue. You could go the other direction, right? I could create this opposite side here or this opposite side here. So I'll go with the slope of negative 1/3. So down 1, 1, 2, 3. So now let's check to see if this creates our parallelogram with a slope of positive 2. So rise is 2 over 1. So here is point P, which is why the answer you should have gotten was B.